In this video, we are going to talk about gas pressure. And in the past topic, we learned that pressure equal to force per unit area. In the case of gas pressure, this concept of force per unit area is still true. I will lead it through by using a simulation of collision between the gas particles and the wall of the container, and to illustrate this point. In this empty container, there's nothing inside, there's not a single thing, it is vacuum. So you can see that the pressure gauge indicates zero pressure. In the next moment, I'm going to pump in some gas particles into the container. As the gas particles are being pumped in, I want you to look at the pressure gauge. The pressure is rising. Now observe the collision between the gas particles and the wall of the container. The collision between the gas particles and the wall of the container give rise to gas pressure. Let's go through some concepts. Motion of molecules and pressure. Moving gas molecules collide with the inner wall of the container and exert a force on it. As you can see from an enlarged diagram showing the inner wall of the container, when a particle of gas collides with the wall of the container, it exerts a force onto the wall of the container. And there are many gas particles colliding on the wall of the container everywhere at the same time. This gives rise to an average force exerted on the wall. On the left, you can see the pictorial representation of the collision. And on the right, you can see the actual simulation of the collision. Now, the force exerted per unit area is thus called the gas pressure. So, in summary, moving gas molecule collide with the inner wall of the container and exert a force on it. The force exerted per unit area is thus called the gas pressure. And now, let's connect back to the pressure topic that we learned in the past. Pressure equal to force per unit area. So in gas, that gas pressure is due to force per unit area exerted by the gas particles when they collide with the wall of the container.